Good morning. This is Teradeep status on vision recognition for cameras. In home automation, you've seen the development of IP cameras that stream continuously data over the internet. At Teradeep, we don't want to waste any more time looking for events or days and days of video streamed to a cloud service. What we want to do is create an embedded device that can detect objects of interest, for example, person, pets, or any object that you might be interested in. It will record the frames with the object of interest. It will record the short movie clip around the object of interest appearance or disappearance. It will create a timeline of events with full time and date. Your user will have a quick navigation to month, day. They'll be able to select object of interest that they want to see and have recognized, and they will be able to list objects for each camera that they have at home or around the home. They will be able to select movie length and detection threshold, and also delete and search for detection over a period of time. This is the PODA home automation device from Teradeep. As you can see on the right, we have a timeline of events, and for each timeline of the events, at the bottom you have what happened during the day. Here you see a small movie of a car delivery truck that delivered a package to my house. You can then browse for more frames, individual frames, or movies around this kind of event. The same can be done inside the home, where in this case we recorded the long time sequence of still images around the home, and you can see precisely in the bottom timeline when a person was detected and what kind of object was detected. In this case, we were looking for a person. So this is a simple embedded vision system that uses a cell phone processor like and is able to process video in real time at few frames per second, and be able to record and compress video in MPEG-4 and send it to the cloud whenever there's a person in the scene, just like in this case here. Whenever we see a person appear in the scene, for example in this case a delivery truck, we can record a movie that is 10 seconds before, 10 seconds after, or a certain amount of time that any user would like to have. So here you can see different kind of images that have been detected inside the home. You can see that when we detect person, images can be blurry, person can be in any position, and doesn't have to be front facing. This is not the face recognition, but it's really a full developed person recognition with any posture, any distance, and any kind. What we want to head on right now at Teradeep is face recognition at home. We are working on recognizing family members, ignore known people if desired, that detect unknown identities and send the warnings, or only detect people of interest. We want to create a simple manage identities and user interface so that people don't have to spend a lot of time to train the system to detect the people who they want to detect, or the new members or the unknown identities, without spending hours. Our cloud system includes an image recognition API. So we go way beyond person identification or pet identification or car identification. We can actually recognize thousands of objects. We have a private data set with state-of-the-art results. At the moment, we train on 10 million plus images, but we have a data set of 32 million images. These are real-life useful objects. Their specialty is home automation. They have indoor, outdoor, around the home, with people and demographic and pets and multi-breeds. So it's a very large data set that people can train and recognize pretty much any kind of home or home automation related object that might be interesting. So here you see an example of our general object recognition capability. This is a network trained with 1,000 objects, each one with 10,000 samples on a 10 million object data set. So this is 10 times bigger than the state-of-the-art data set that has been used publicly. As you can see, recognition is extremely precise for a lot of objects inside the home. And we use a very lightweight network, in this case running on a small laptop. It runs at about 20 frames per second or above. In an embedded system, it will run at a few frames per second, depending on the processor speed. You can see can detect even ceiling, floor, and other objects that are extremely hard to detect with other computer vision techniques. This is one of the beauty of using deep learning and large data sets. On top of this, our data set includes a full caption. So as you can see, a lot of the words that appear here can actually describe the scene, not only the main objects that we see, but can also describe a part of the scene quite reliably. Like in this case. This general object recognition has an API which we can send the images to from a web interface as well. So even other cameras and other systems that don't have recognition capabilities can send frames or short videos to our web API system. It can parse both images and videos. In this case, we see a few examples of images. They are extremely rich, and one of the best state-of-the-art system out there at the moment, especially for home automation. They report results like in this case of Avril Lavigne, where they clearly describe many of the objects in the scene much better than other systems trained on ImageNet dataset on other datasets. Our image recognition APIs also include face recognition. We have state-of-the-art like Picasa face detection of faces. We can create multiple face datasets. For example, different dataset for inside or outside the home. We can add new faces to the set, train new face set, recognize faces, and cluster similar faces. Can detect the new unseen faces and create warnings if necessary. We can also search for a face. When did this person appear in my house or last? We can visualize all the faces, and we can delete and rename and stats. So this is all an effort to create a nice user interface for user to manage face identities really easily with click or even with a touch application on Android, in a simple way to tell which person do they want to be notified about, which people do they want to follow, which one do they want to ignore. If it's a family member, obviously you want to ignore them. This is our face recognition dataset. Uses the face alignment at the moment and face identification, but you can create your own set and train your own set. In this case, for example, we train on 83 identities of famous people, but then we retrained part of the system to recognize just our lab members. Here is very precise and recognize all the lab members extremely precisely, although as you can see, this network was trained without having seen these people at all. At the same time, we want to cluster images and give a similar ability to Picasa, the Google Picasa system. So we want to cluster faces together, detect the known and detect the new faces. And giving this kind of abilities allows people to clearly mark groups of faces as, okay, there's somebody from the family, mark them and create their own identity set, and create a target list and an ignore list very quickly. We thank you for your time, and we hope to work with you.